This is Algebra 1, Lesson 2C. We're going to be talking about triangles. Start off with a question for you. What is the polygon with the fewest number of sides? Can I have a one-sided polygon? Well, it wouldn't be closed. Can I have a two-sided polygon? It also would not be closed. A three-sided polygon. So, yes, you guessed it. It's a triangle. The polygon with the fewest number of sides is a triangle. So let's talk about something else. What is the sum? Sum is an answer to an addition problem of the measures of the angles of a triangle. So here's an angle, here's an angle, and here's an angle. And they're not necessarily equal. But when I add those up, what do I get? And how do I know? Well, I want us to use a tool called GeoGebra to just explore that for just a second. So let's use GeoGebra. I'm going to full screen it here. Now, you can see we've got a triangle here, and it's already, the program measures the angles for us, and you can see the purple angle is 30 degrees, the green angle is 90 degrees, and the, I guess, red or pink angle is 60 degrees. Now, I can manipulate that, but one of your terms you're going to learn for this lesson is right. We've talked about it a couple times already. A right angle is 90 degrees. So we see our green angle. Now, look what they've done up here. They've done the math for us. They said, well, we know the green one's 90, the red one's 60, and the purple one's 30. If you add all those up, you get 180 degrees. I want you to keep an eye on that sum, that total of the addition of the three angles. And I'm going to grab a vertex or a corner on this triangle and I'm going to move it. Okay? Now watch. If I stop right here, now I don't have a right triangle anymore. The green one is 103 degrees, the red one's 51, and the purple one's 26. But what happened to my sum? Still 180. Because as the green angle grew bigger, look what happened to the purple angle. It has to get smaller or I break apart my triangle, right? And I can go way down here to where I have a really huge green angle and really tiny purple and red angles. Or I can go back the other way. But look what happens to the sum as I'm moving it. Nothing. Because as the angles change, the others adjust. I can have a 90-degree angle right here, where the purple is the 90-degree angle. So what do you notice about this? The sum of the angles of a triangle, and I can manipulate all of them, have to be equal to 180. I'm going to put this over here for a second. See if I can get it to where they're all equal. It's kind of hard to do. Close. What if I come in a little? And you can do this too. I put the link in the notes and I'm going to post the notes. Oh, I'm pretty close. If we were to be able to get all three of those angles equal to each other, what would all of the angles be? And you can try that yourself. I'm going to go back to our notes page. Here's the link for the GeoGebra demo. That's a cool thing that you can use to work on these. Let's talk about some of those terms, and I mentioned some of them while we were doing the activity. Let's look at the diagram. So we talked about a right triangle. It's going to have a right angle in it, and we've got a picture of one right here. So if you notice in this diagram, the ones in the pink are descriptors based on angles, the angles of the triangle, okay? The ones in the blue are based on the sides. You know, we categorize all kinds of things. Like you can look at your shoes in your closet and you can say, well, some of my shoes are, you can sort them by color. or you can talk to me about how tall they are, or how heavy they are, or whatever, right? We can classify them on different things. So it's the same thing with triangles. If we want to classify them based on their angles, we're going to call them either right or acute or obtuse. And that's what these terms are in your lesson. So a right triangle has to have one right angle. It can't have more than one right angle. That's impossible. And you can explore that a little bit with GeoGebra and prove it to yourself. An acute triangle is going to have all acute angles. And an obtuse triangle is going to have one obtuse angle. You can't have more than one obtuse angle in a triangle. So that's how you name them, based on their angles. But we could also talk about them based on their sides. An equilateral, actually first here is an equiangular triangle. We're going to talk about that one in just a second. We'll come back to that one. Let's talk about an equilateral. We'll jump down to this one right here. Equilateral triangle just means all the sides are the same, okay? And let's zoom in here and look at this. They've got the tick marks. They're showing this one's equal to this one, equal to this one. And it gives us a little clue right here. It says, if all of your sides are equal, all of your angles are going to have to be equal too. And you noticed when I was working on GeoGebra, as I moved the angles, the side lengths had to change because they're connected. So all of these angles are going to have to be 60 degrees. So I'm just going to also mark that. Now, they didn't mark that because here they're trying to tell me something based on the sides, but we can see that that's true. So an equilateral triangle, all of the sides are going to be equal, but it also teaches us a little bit about all of the angles are going to be equal, and they're all going to be 60 degrees. Now, why are they all going to be 60 degrees? Well, we know that all of the angles in a triangle have to add up to 180. And if they're all equal, then let's divide that by 3 and you get 60. So each one's going to have to be 60 degrees. Another type of triangle based on the sides of the triangle is an isosceles triangle. And an isosceles triangle, 2 of your sides or more are going to have to be equal. Okay? And it shows you here in the picture, they've got tick marks just on these 2 sides, and they'll call those the legs. Okay, and what we will also learn is that means that the angles across from those sides are going to have to be equal. And so if those angles are also going to be equal, then we could put this angle is equal to this angle. Now, I think it's kind of cool in the word isosceles. Do you see that you've got the S and the S? That kind of helps me think about this. It's like this is the S, and this is the S, and this is the O. So you got the SOS. That might help you remember what an isosceles triangle looks like and is. It's got at least two equal sides, and then the corresponding angles are equal. Another term that you have here is, we talked about isosceles, is scalene. Scalene means that none of the angles are equal and none of the sides are equal, okay? And so that's the last term describing triangles. Now, I've got another note here. The lengths of the sides of a triangle and the measures of the angles opposite of these sides are related. And we saw that in GeoGebra, and I encourage you to try to play around with those a little bit and see what you can learn, but just by manipulating those sides and angles.